clockwise. So G02 here will be used for the clockwise, while G03 will be used for the counterclockwise. So when we say clockwise, that means it's the same direction of the clock. So clockwise G02. If your movement, I mean, when we said clockwise, that means this is the start point, and here is the end point. So it's go in this direction, so we call it clockwise. So we are going to use the G02. But if the movement of the tool or spindle is required to go from this start point to the end here, so this will be counterclockwise. We are going to use the G03. So for the both code here, either G01, 2 or G03, we are going to define some parameters, which is in addition to the existing coordinate, which is X, Y, Z. I mean, X, Y, Z, this will be the point of the destination point. Like if I am here at the start, this will be the coordinate for the end point. If I am here at the start point, this will be the coordinate of the end point. But in addition to these points, because we are not going to move directly, I mean, it will not be like a line, it will not be like straight line like in the linear interpolation. So we are going to go with a circle here or semicircle or arc. So in this case, we need to define more parameters, which is I, J, and K. So I is the difference between the start point and the center of the arc. So each arc here, whatever small or big, is it half circle, I mean semicircle, or full circle, or a part of the circle, or small arc, or they have the radius here. So the radius are here and it has a center. So we can define by the two way, either when we use the center of the arc or the center of the semicircle or the center of the circle here, we are going to use this parameter I and J and K. If we have two coordinates, it will be IJ. If we have three coordinates, it will be IJK. Okay. In the case we have the radius already, I mean the value of R. So in this case, we are going to use R only. No need to use I and J and K. Okay. So it depends. If you are in your in the example here or in the question, you only given the value of the center or the coordinate of the center of the arc. In this case, you are going to use these coordinates I, J, K, which is I mean the distance between or the length between the start point and the center of the arc. Start point, this is the start point and the center of the arc. If we want to move counterclockwise, this is the start point. If we want to move counterclockwise, I mean this is counterclockwise, this clockwise, this is counterclockwise. So here this is the start point, this is the start point. So the difference between or the coordinate of this point to the center, which is I on the x-axis, J on the y-axis. So this will be used for our coding format. So as we can see here, this is the format here. So N is the sequence of the or the block number. We are going to use either G02 if it's clockwise, G03 if it's counterclockwise. Then we are going to specify the coordinate for the end point or the target point. Then we are going to highlight the value of I, J, K. After that, we need to highlight the feed rate, the value of the feed rate. In the case of using the radius already known, that means we have the value of the radius. So we are going to define X, Y, Z. Then we define the value of the radius, then the feed rate. No need to have these three I, J, K. So this is two ways to use this circular interpolation in the G code. Okay. In addition to these two ways, we have another two ways because since this one is more focused on the, for example, it can be like absolute or it can be incremental. So these two become four. In the case of absolute, they are two. In the case of the incremental, they are two. So as we can see here, this is for the case that you only given the value of R's. The R, I mean the center here. The center of the arc, you do not have the value of the radius. So if you have the center of the arc, so for sure you are going to use the I and J here. If you have 2 coordinates, if you have 3 coordinates, you are going to use I, J, K. So what is the value of I? What is the value of J? It's use this equation to find the value or the coordinate of I and J and K. So the value of I or the coordinate of I is equal to X coordinate of the center. So this center will be exist at this point, X coordinate, X, Y, Z, for example, if it's 3 or X, Y if it's 2. So here, this is the coordinate. You want to find I is equal to X here of the center minus X of the start point. This is the start point here. So I is equal to X of the center minus X of the start point. J is equal to Y of the center minus Y of the start point. K is equal to Z of the center minus Z of the start point. So we need to find the 3 values here. Then these 3 values will be integrated into the G02 or G03 codes. In the case we have the radius here or the arc radius, so in this case we no need to calculate the value of I and J and K. We just going to use the value of R. So here we need to the block format or the code format of the block here will be N, the sequence or the number of the block, G02 or G03, X, Y, Z. In the case you have 3 coordinates, then you are going to highlight the value of R, which is the radius. After R, we have the field rate. So this is how to define the trajectory for the movement in a circular interpolation. So we are not going, as we said, this will not start point to the end point directly. It's not like this one. So there is a circular interpolation. So in this case, the machine or the spindle need to move within this radius or within this distance from the radius. So all this will R, all this value R. So all the point here should be located with the distance of R from the center of the arc or the center of the semicircle or the circle. The direction or the conventional method to define the clockwise and counterclockwise based on the plane that we are consider. If you are going to use XY plane, so this will be clockwise, this will be counterclockwise. If you are going to use XZ, there will be another direction. If you are going to use ZY, there will be plane, there will be another direction also, as you can see. But always the clockwise is in the same direction of the clock, but the location of this clockwise and counterclockwise depends also on the plane that we are going to consider. So in the case we have, we are using the absolute value as we said, which is G90. So the coordinates of X, Y, Z, and also the for the target point will be reference to the 0, 0 axis. If we are going to use the G91, so the coordinate here will be different because we are going to use the incremental coordinate and it will be reference to the previous point, as we already mentioned before about the G90 and G91. So here we can see how we can define the value of I and J and how important is the sign of I and J. Actually, I and J should be indicated with their sign. That means if it's positive, so they are positive, it's negative, so we need to highlight it is negative. So as you can see here, if this one is the start point of the, of our trajectory for the circular interpolation, so the distance from this point to the x-axis is represent the value of J, correct? So because this is the start point here, and here we have the y, the x-axis, so that this value represents the value of y, because we said y is equal to the coordinate of y at the start point of the center minus the coordinate of y at the start point. So from this point to this point, what will be the difference in the y-axis from the center? What is the difference of the center and this point? It is the same like you put here. This is the change in the value of y, which is equal to J. So here j is equal to this j, correct? So this is the difference or the value or of j between the center and the start point. But the value of x here will be from the center to this point is represent the value of I here. So if this one is less than that value, for example, this is 7, this one is 9. Okay, so what is the value of I here? It will be 7 minus 9, so it will be -2. If the arc is placed on the other way, I mean the center is placed on the other way, the center of the arc is here, like this one. So in this case, it will be positive I, not negative I. Same case is applicable for the j value. So either x, I mean the coordinates from the x or the coordinate from the y between the center and the start point, both should be indicate either positive or negative. So in this case, we can understand what is the direction of the movement from the start point of the arc to the end point of the arc. So here we said we already have, when we consider the value of, I mean the absolute coordinate and incremental coordinate, so we will have four codes or four formats to write this code. First, using R, Ij, this is all absolute. Then use R, Ij, this is for the incremental. So four ways to write the format of this G02 and G03 code. What we need to fill up here in the dash, it is the coordinates of x, the coordinate of y, the value of the radius, the coordinate of I, the coordinate of j, and also the value of the feed rate. As we can see here, we have example just to see how we can apply this G02 and G03 code at the circular point, in addition to the G01, which is the linear point. So we have a path, we want to draw a path for this point. Starting from here, this is the start point, and this is the end point. As you can see here, this is the end point, and here we have the start point. So we want the spindle to move from this point until reach to the end point. So in this case, we have two movement which is depend on circular interpolation from this point until here, this circular interpolation. Then from this point until that point, this will be linear interpolation. Then from this point to this point, this will be another circular interpolation. So here, this is linear. This one is linear because it's this point and that point at the same level. So this is straight line, So the straight line here is from this point to that point. So we are going to use the G01 movement. From this point to that point, this one is a arc. So the arc, it has a radius of 20 here. So we are going to define the code for G02 or G03. So how I know is G02 or G03? I need to highlight the direction. So this will be according to this arrow here. It will move counterclockwise. So since it's counterclockwise, we are going to use G03. Okay, for this way here, the direction will be that way. So from this point to that point, it will be clockwise. Okay. So how to define the coordinate of x and y? According to this value that it is given here, in addition to the value of r. So as we can see here, for the absolute mode or absolute coordinate here, we are going to define the G01. This is G01 movement first, the first movement from our linear movement to the value of x, because in the beginning, the machine or the spindle will be placed on the 0, point. So I want to move the spindle from this point until the start point. So like this line. It's a straight line. So we are going to use linear movement. So G01. I can use also the fast or the rapid traverse or the fast movement. I can use G00. So in both cases, we are going to reach to this point, which is the start point. The start point coordinate is x is equal to 40 plus 20 plus 20 plus 20. So it is 100. This is the value of x. The value of y here, it is 40. So this is the value of y, 40. And the speed, this feed rate, we said there is a list or a table for feed rate. Depends on the type of material for the spindle or for the tool. Depends on the type of the piece, work piece, and so on. So as you can see here in our example, we just put one of these values. That is, there is a table for feed rate, table of the speeds, and this feed rate and speed are calculated based on several parameters related to the tool diameter, related to the speed, and so on. So assume this feed rate for this example is F125 based on this the given value. I mean, don't say what from where I got this one. In the question later on, or in the complete example, you will be given this value, or you will be asked to calculate this value based on some given information according to the formula that we have before for the feed rate, or the formula for the data, I mean, either for feed rate or for the spindle speed. Either you will be given the parameters to calculate the value, or you will be given these values for the feed rate or for the speed and so on. But here our focus more on how to use these G codes. Okay. So this is the spindle is reached to this point. This is the start point or start position of our work. Now we want to move from this point to that point. So this is circular interpolation. So in order to, and I have the value of R. Since you have the value of R, no need to use the IJ or IJK. So you just use the value of R. Since the, I mean the value here, or the, I mean the R is smaller than 180, you just use the value of the 180. If you want to apply the formula by using, we said here, we have 4 ways to represent. I can use R, I can use IJ, I and J. So if you give an R, you use R, it will be okay. Just use R. If you want to understand how we can calculate the value of K, so this is how to calculate the value of R and J. Okay. So instead of this one, I can use just directly R20 instead of like we do here. Okay. This is R20. So in this case, we use R. In this case, we use IJ, just to show you how to calculate the value of I and J. Okay. So the start point is here. What is the coordinate of start point here? It is X is equal to 100 and Y is equal to 40. This is the start point. What is the destination here? The destination is X is equal to 80 and Y is equal to 20 plus 40, it will be 60. Okay, so this is X, this is Y, this is X, this is Y. Okay, now after we move the spindle here to this point or to start point, then we will ask the spindle to go counterclockwise. So counterclockwise, we are going to use G03. So G03, go to X80 and Y60 with the I equal to -20. How to know the I is equal to -20? Because the distance between for the X coordinate from the start point to the center, this is equal to 20. So the distance, this is I here. This is the value of I. It is center value, which is 80, minus start point, which is 100. So 80 minus 100 is equal to -20. So we said I is equal to -20. What is the value here? If we said what is the value of J, the value of J is equal to the center point, which is here. Okay, center point is located at Y is equal to 40. So this is the center point Y, which is 40. What is the start point Y here? It is also 40 because this is on the same level. The start point and the center are on the same level. For the value of J here is equal to 40 minus 40, it is 0. So no need to write here J0 because it's already 0, no need to write. Since there is no movement on the J, so no need to highlight the value of J. So in this case, we only focus, I mean, we only consider the value of I only. Okay. After the movement to this point, I want the spindle to move from this point to that point, and this will be linear interpolation. So linear interpolation just define G01. This is G01, and the movement is on the x-axis. The y-axis is fixed, which is at the 60 here, no need to consider. So the movement only on the x-axis by from 80 to 60. So here the movement on the x-axis will be 60 only. Okay, this is the 60 because 40, 20, this is the coordinate of this point is 60x and 60y. So from 60 to 60, no change. So no need to highlight for y, but here from 80 to 60, there will be change. So since I'm using absolute mode, so just highlight the value of 60 with respect to the reference point. Okay. When the spindle reach to this point, need to move to the next point, which is the end position here. This will be movement linear interpolation clockwise. Clockwise, that means we are going to use G02. Okay, so from this point to that point with clockwise, since I have R, I can use just R directly. If I want to use I, so I want to define what is the change in the value of the I and the value of the J. Still the same because this is not my start point. The start point is here. So we said when we define I and J, it's not from the current point, no, from the start position. So we already defined that I equal to -20 and J is equal to 0. So no need to redefine again. You just use I -20. And what is the destination? The destination is at this point. This point we have X is equal to 40 and Y is equal to 40. So for that we have X40, Y40. We said if we want to use R, you just use R, R20, R20. Okay, so the R here, the R also, it has two values. It can be positive and negative. When R will be positive, if the R or the semicircle here, I mean if the size of the R from the start point to the end point is less than 180. I mean 180 means semicircle. If your arc is up to semicircle, you are going to use R positive. If your arc is more than semicircle, that means reach to this point, reach to that point, and so on. So in this case, R will be negative R, as we will see later on. Okay. The second one here, when we use to when we are going to define the incremental mode. So in the case of incremental mode, and we use G91. So in this case here, the incremental mode, the value that will be changed only the value of the X and Y coordinates, this value only. The others are still the same, are still the same, nothing changed. Only the, the coordinates says the value, this is the reference point for this point, and this will be the reference point for that point, and this one will be the reference point for the end position. So when we reach to here, we are going to, if we want to define the coordinates, X minus X, Y minus Y, here X minus X, Y minus Y, and so on. So this is the only difference between the incremental mode and the absolute mode. So this is that we already mentioned for the value of R. So R is positive, we said in the case of it is less than 180. So you have R is small, it's not a complete semicircle, it's not a complete circle. So less than a semicircle, so the R is become positive. But if in the case for if we have the R is more than negative value, I mean more than a semicircle, so it will be a negative value. As you can see here, if I want to define, this is the start point here. In this figure, this is the start point. If I'm talking about this end position, through the circle A, this one I have circle A, here we have the circle B. So in the circle A here, if I go through this line from the start point to the end position, so in this case, the arc is small, is less than 180. So in this case, R will become positive. But if I want to move through this from this point through circle B, okay, that means you can see here is almost a complete circle, only less this part. Okay, so in this case, it is more than 180 because the 180 will be like this one. If it is until this point, it will be less than 180. But if it's more, so in this case, it's become the value of R become negative. So we are going to use the negative value of R. So this is the difference between the G02, G03 for the, and the difference between the value of I and the value of R, and how we define the positive and negative values. Any question until here? You still there? One answer at least.
Yes, sir.
Okay. Khairul, okay. Ikmal, okay. Okay, so let's continue. Next, the next code here, or the next G code, is G04 for dwell, and this usually used for the with the drilling here. I mean, in the drilling process, sometimes you need to move the machine, I mean the spindle, and you want it to stop at specific point before perform the task. I mean, before do the drilling. So you want the spindle to move to some place, and then this spindle stop here, but still rotating. I mean, but not touch the body, I mean the workpiece. So in this case, we are going to use the G04. So after G04, we need to define for how long we want this spindle or this tool to be stopped. I mean, how many seconds? So for example, we are going to use this formula. N30 for G04, B2. So the letter B here is used to define the period of time that we want the spindle to be in the dwell or in the idle mode, rotating in the idle mode here for 2 seconds. So the spindle move from one point to other point, then start rotating for 2 seconds, then it will go through the workpiece here to create the hole, for example. So it move, stop for a while, 2 seconds, then perform the task. Okay, this is the blend that we mentioned before. We said we I mean the conventional for clockwise and counterclockwise defined according to the plane. So if you have if you are going to use the G17 or XY plane, so this is the clockwise, this is the counterclockwise. So this is if we are going to use the XY plane. XY plane means the top here, like the top view of your I mean of the machine table. So if you work on the XZ or ZX plane, so this will be the counterclockwise and this will be the clockwise. In the Z plane, you can see here how change is just G02 here for counterclockwise. This for, I mean for clockwise, this will be for counterclockwise if you are working on the ZX plane. If you work from the front view here, I mean from the right side, this is front, this is from the right side view. From the right side view, this will be the clockwise, this will be the counterclockwise. So it depends on the plane that we have, the G02 and G03 for the circular interpolation will be defined, or the direction of G02 and G03 will be defined. So this G17, 18, 19 will be used to define the plane, the XY plane or the XZ plane or the ZY plane that we are going to perform the task on it. And it depends on, I mean, if you have workpiece, this workpiece, for example, it's like 3D here. So depends, you are working on this area, you are working on this area, or you are working on that area. So in each case, the counterclockwise and clockwise will be considered based on the plane. Same here. This will be, I mean, this will, I mean, when we, or the place or the location of your, of the, I mean, the coordinates for G0 counterclockwise and clockwise command will be affected based on the command of the G41, G42, G81, G89. You can refer for this place here. So the machine application or these coordinates here or this plane, the plane here that we are going to work on or select based on these three commands 17, 18, 19 will be more effect or have more critical effect on several code only. I mean, for other code, for example, for movement, there is no effect. So for example, if you are working either here or this plane or that plane, and the machine is, the command to the machine is 000, so whatever is, you are working here, there, or there, nothing changed. It's not that critical effect, or no need to consider here for the motion with the G00, for example. And all linear motion here, like G01 and G02 and G01 here, the plane selection command is not needed. I mean, if you work with XY or ZY or XZ, no need to define the plane in the case of G00 and G01. But in the case of G02, G03, it has direct effect. As you can see here, as we said, this is now in this plane, G03 is not the same like in this plane. In this plane, this is G02, this one is G03. But if you work in the XZ, in the ZX plane, this become clockwise, this become counterclockwise. Okay. So that means the plane or the machine tool planes here has a direct effect on the G2 and G3, and also the cutter radius offset like G41, G42 commands, also the fixed cycle with G480 and G89. All these will be affected by the plane. But the movement is either linear movement, I mean fast or rapid motion here, and also the linear movement, it will not be affected by the plane here. So selection of one plane here will cancel any other plane. So if you said, if you select G17, for example, that means G17 will cancel G18, will cancel G19. So if you work on XY plane, you cannot work on XZ or X or ZY, because if you want to work on XZ and you need to use this again, this other command. So according to her, G17 give you XY. If you run G17, it will cancel G18 and G19. If you run G18, it will cancel G17 and G19. So every time you run or you select the plane, it will cancel the previous commands for the plane selection. So this is the G17 here. You can see in the G17 we are working on the XY plane. So XY plane represent the top of the workpiece here. So you are working here in the on the top of the workpiece in this phase or in this plane. So imagine that you have, this is the spindle tool. So the spindle tool, if you want to make like drill, I mean hole, or want to do milling for this part and so on. So or in this case we need to select G17. So all the work by the machine will be done on this XY plane. So for example here, as you can see, this part is created by using these two spindle here. So on the XY plane. In this case, the Z axis here represent a secondary, because what is the primary here? The primary are X and Y, but Z is represent secondary workpiece. So it is usually perpendicular on this XY. This is XY, and this is the Z axis here, which is perpendicular to XY. Okay, so how to use the command? This is the command for using the XY plane, which is N line, I mean the block number, and then we have G17. For the case of G18, we are going to use the XZ plane, and the XZ plane is more on the like the front, I mean the front view here. So this is front view, this is top, so this is right side. So for the front view here, you are going to work on this side. So if these two machines, I mean two spindle here, located on the border of this workpiece, so the impact of this work will be like make a circle, a semicircle or arc on the this side. As you can see, this is the impact here on the G18. So if the work is more on this side, so you need to define the G18 plane. If the work more on the top, so you are going to define the G17. If the work is more on the right side, so you are going to use G19. And in each case, we said the given command for G will cancel or the previous command. So this plane here, I mean, in this case, the X and Z are primary and the Y is secondary axis, and it's also perpendicular to the xz plane. So you can see here, if this is x and z, and the y here, or the y axis, which is come from this way, it will be perpendicular to this xz plane. Same for the G19 or YZ plane here. Our focus will be more on the right side plane, and here the Z and Y are the plane, and X is the will be perpendicular on this YZ axis. The code is NG19. These two commands are two general commands and will be applicable for the whole codes to define the measurement standard. So either G20, which use the for empirical or inch units, or G21, which used for the metric or millimeter units. Okay, so for example, you want to use your drawings is based on millimeter, so directly you are going to use G21 for your program. If your measurement or coordinate based on inch, so you are going to use the G20 as in the beginning of your program. Okay, so when you talk G20, so all your measurement, all your coordinate will be measured in inch. If you use G21, all will be in millimeter. So just place this G20 or G21 in your program. The reference point here that we already mentioned before about the reference and the offset for the machines. So we are going to use the G28. If you are working in any place on the machine table and you want to send the spindle to the reference point, so in this case you need to use the G28. For example, we are working for in X at this point here, which is X is equal to 70, Y is equal to 30. Then I finish my task here. Before I go to the next hole, for example, or to the next action or to the next place, I need to send the machine, for example, to the 0 point. So just use G28. It's not compulsory, but it depends on the need of the work. Do the spindle need to go to the reference point or not? Sometimes in the work, you cannot go from one point to another point directly because there is some obstacles in between, or you are going to touch the corner of the workpiece and so on. So the solution is just return the spindle to the reference point, use this G28. Then from the reference point again, go to the next point. So because you are not going to work always with a uniform shape or uniform workpiece. Sometimes the workpiece, it has a lot of graded lines, round and so on. There are many holes and so on. So you are going to define, instead of move from one point to another point, for example, you want to return to the reference point, then go again to the next point, or you want to change the tool, you want to go to the reference point, for example, you want to change tool and then take another action. So in this case, you need to go for using the G28. So the format here for the absolute or for incremental, you need to define the value of absolute or incremental by using G91 or G90. Then you go for the reference point. Here, after reference point, you need to define, this is usually the main reference point, x0, y0, z0. In this case, if it's x0, y0, z0, the spindle will go directly to the reference point. But if you don't want it to go directly to reference point, you want it to go to one place, like intermediate point, then go to the reference point, because this will be, depends on the shape of the workpiece, depends on is it correct or is it safe to send the spindle from the current position to the reference point. It will not affect the object, it will not affect the workpiece, so you can send it directly. But in case the object has some part or some borders which may touch the spindle during the movement to the reference point, so maybe you need to define some intermediate nodes in between the current point and the reference point. Okay, as we can see here, so here we have two type of movement. If I want to define the movement from this point, this is the start point, and here we have the reference point at B3. This is B3 reference point, and B1 here the start point. So if I ask the spindle to go directly to the reference point by using the command G28, for sure the spindle will go directly here and will touch this place. There is a collision point. This collision point will cause the spindle to touch this point, maybe it will be broken or will affect the project or the object. What we need to do in this case, we need to define some point, intermediate point. So I ask the spindle to move to this intermediate point, which is B2. Then from B2 it can go directly to B3. So in this line there is no collision will be happen with the workpiece here. So this is the difference between go directly to the reference point using the G28 command here. So here G90, G28. I want it to go to the G28 in using the absolute coordinate through X60 and Z60. So where is X60 and Z60? This is the point that I defined. This is X60 here. This is the Y60. So we are going to define this intermediate point. So the spindle in any point will move there first to the intermediate point, which is B2. Then from B2 will go directly to the reference point. But if I do not highlight this intermediate point, which X60, G60, the spindle will move directly to here. It will have a collision with the point here, with the border, with the workpiece. Okay, so this is why we need to define some intermediate point before giving the command for go to the reference point. So this is just it's more clearer to see how this is the start point, and here we go to the reference point. It can, if there is no workpiece here, that means our object is here. You can see here the workpiece is down, so the start point can go directly to this point. So in this case, we don't need to define any any intermediate point. So G28, X0, Y0, Z0. So it will go directly to the reference point without any intermediate point. Why? Because there is no collision will be happen at this if we move from B1 to B3. Any question?